Hey everyone, so in the last video this is the code that we were working with, and we were writing functions. So let me just go through this once again. This is known as the return type of a function. This is what type of value it returns. This is the name of a function, and these are called its parameters or arguments. And let me just add one thing here. These things right here are called the formal parameters, and the ones that you actually pass when you call a function are known as actual parameters. So this is known as a function call, if you remember. So we've written an add function here, and what I want to do now is let's say I want to write a swap function. And what do you think the return type of a swap function should be? Let's just keep it void swap, and it'll take two numbers, int x and int y. And let's just go here and do an a void swap, and int x, int y. And here all I need to do is just create a temporary variable, let's say int t. And the way you swap variables is just assign one of the values to t, then assign this one the value of the other. So x goes into t, y goes into x, and now t goes into y, so that x goes into y indirectly. So that's actually the most simple way to swap variables. If you want to do it without a temporary variable, there are still ways to do that. We do something relate to adding them and all, so you just set x to x plus y and all, but I don't want to talk about that right now. Basically what I've done now is swap these two variables. So let's just go ahead and let's get rid of this and instead write a swap and a comma b, and then just print the values out. A equals %d, b equals %d, and let's just add a \n here, and a and b. So let's try running this. And as you can see, it still printed a equals 1 and b equals 2, which is this thing right here. So what really happened? What actually happened is that this a is being the value that the variable a contained was being copied into the value that the variable x contains now. So let's understand this better by using a pointer. Let's say I have an int star addr underscore a. Let's just do this much for now, and let's print the address. Let's print %p \n and addr underscore a. And here again let's just let's just directly print the value using an ampersand. So %p \n and ampersand x. So here again I need to do an ampersand a, and let's just go ahead and run this. So as you can see, the address of a and address of x that I printed here are actually different. So they actually refer to different variables. It's just that they have the same value. It's like saying that there's a box in my room which contains, let's say, 5 balls, and another one which contains 3 balls. I just tell you that these are the values, and you make your own boxes, and you swap the number of balls in the boxes, but that does not change the balls that are in my boxes. So the way to actually swap is slightly different, and let's first just get rid of all of this. This is actually just making our code messy. Let's get rid of this as well, and this. So the simple way to swap this from the analogy that I told you would be to just tell you what room I have, and you can just go into my room and change the boxes. So when I tell you what room I occupy, it just means giving you my address. So what I can do here is I call swap with the address of A and the address of B. So I'm giving you the addresses of these variables, and now all you have to do is just go to this address and change the values there. So here I'll have to mention that x and y are not actually integers, but the addresses of integers. So these are addresses of integers that I'm passing here. So what I do here is let's just get rid of this first, and let's just make this in star so that these are pointers now. And all I have to do is I need to create an int, and now this t should contain whatever value is at this address x. So I just need to add a star here, and if you remember, a star means at address. So t now contains the value at address x, and I now want to set the value at address x. So at address x, assign whatever is at address y, and again here at address y, just assign whatever is in t now. And let's just try this out. Let's just go ahead and compile it now, and I didn't really print anything here, so let's just do a printf. A equals %d, b equals %t, and a comma b. Let's just compile it again and run it now, and as you can see, the variables have been swapped alright. So once again, let's just go through this. What I've given this function of swap is the addresses of these variables, and then here the swapping that we are performing is based on these addresses. So I'm swapping whatever value was at address x and whatever value was at address y. That's what's going on here. And the first one that we talked about was something like this. Let's say a comma b. This is known as passing the arguments by value. So this is known as passing by value, and we call passing by address as passing by reference. So when we pass addresses, it's called passing by reference, and when we pass the actual values, it's called passing by value. So this swap function here is a pass by reference function. Also, you might wonder why I just didn't take two values and return two values. The reason for that is because I can't do that. I'm only allowed to return one value, so I can only have a return x, or I can return y, or I can return t, whatever I want, but I can't do a return t comma x. And that actually makes sense, because what do I accept this in? For example, how do I write this? Do I write t comma x equals swap? That doesn't make too much sense. So all of that is wrong. I can only return one value, but then I can't implement something like swapping two variables using a function. So that's why we have the passing by reference, and this is actually useful in a lot of other cases as well. So this is something that I wanted to point out. And another thing that I want to point out here is that I can actually call functions from within functions. So let's just get rid of all of this for now. Alright, this reminds me, I can also define functions before main itself. So if I write the function here, and in that case I don't even need to write the declaration for a function. What I can do is something like this: void fun1 and void fun2, and I can just define them here. That's what I'm going to do right now, and in that case I don't need to give a declaration. So here I can actually just do a printf. Let's say I print function 1, and this here let's just do a printf function 2, and here let's just call function 2, and here let's just call function 1. So what's going on now is I'm calling function 1 from main, so it goes here, and here it realizes that it needs to print function 1. That's what it does, and then it goes to function 2. In function 2 it prints function 2, and then it hits this brace, and a brace means that a function has ended, and the control should go back to whatever called this function. So the control goes back to function 1, and then it realizes that it has hit the ending brace of function 1 as well. So control goes back to main, and here we encounter a return statement, so that terminates the program. So let's just run this once. Alright, this should be fine. These are just warnings. If I run this now, it actually prints out function 1, function 2 in one line, because as usual I forgot to give the \n. So we are actually allowed to do that, and a simple way to explain how this works is we have main like this. This is our main, and next we call a function 1. So what happens is there's a function 1 that is created on top of main, and then there's a function 2 which is called, which is created on top of function 1, and when this sorry about that, when this function 2 finishes, it just disappears and function 1 appears again, and when this finishes, this disappears as well, and it just goes back to main. So that's what happens. This is actually known as a function stack, because functions are stacked on top of one another. So this is something that I wanted to mention, and there's still some things left about functions which we need to talk about. So we'll do that in the next video.